What the heck does R2-D2 have to do with the nature of force? And what does this have to do with Aristotle, Galileo, and Newton? Okay, here we go. Starting with the quiz. It's a video quiz, so you have to watch this video. This is R2-D2 flying in Star Wars Episode 2. There's no sound, so I'll make the sound effects. Okay, there. Now, here's a little bonus picture to help you answer the quiz. And it's not showing the picture, so let me go back. There's a picture. Okay, so there's R2-D2 flying. Notice that while he's flying at a constant speed, he has his thrusters pointed back. And then while he's stopping, he points his thrusters straight down. That's partially important for the video quiz. Okay, now for the quiz. What is wrong with the flying R2-D2? A, nothing. This is fine. This is what George Lucas really wanted in the original Star Wars, but he couldn't do it. And there's a trick question. Yes, I'm joking around about the Commodore 64, but this is a funny joke. Okay, why didn't R2-D2 fly in the original trilogy? C, he wouldn't fly that way. Or D, droids are not allowed in the cantina and they shouldn't be allowed to fly. Okay, I'm not going to tell you the answer. Instead, let's think about Aristotle and Newton. Okay, so on the left, we have Aristotle, and that's actually a picture of a statue of Aristotle. And on the right is a picture of Isaac Newton. So what do these two people think about the way R2-D2 flies? And why should we talk about them? Yes, there is another important person, and that's Galileo. Everyone kind of says, oh, no, don't worry about Galileo. He's just Galileo. But he is important, and we'll talk about them in a second. Let's look at another example. Here's a block. I push it on a table, it moves, and it stops. So how do we deal with this block in terms of the way Aristotle thinks of physics? And more importantly, what does Aristotle think about science? So this is the way the Greeks thought about science. They used deductive logic, deductive reasoning. So they would take something that we all assume is true, things stop. Okay, when you push them, they stop. The block stops. We assume it to be true. And it's true, right? The block did stop. If that's true, then what can we figure out from that thing? So we take some big idea that we assume to be true, and then we figure out all the details. I don't have a good example here, but we could say things like, well, blocks want to be at rest, and things about violent forces, which I'm going to talk about in a little bit. But this is the way Sherlock Holmes thinks. Oh, well, I saw this piece of evidence, therefore these things must be true. That's deductive reasoning. So in terms of deductive reasoning, Aristotle has the following ideas of physics. There are two kinds of interactions. The first are natural interactions. So if I take a ball and let it go, it falls. That's what balls want to do. That's natural. And it's kind of related to this 4 or 5, there's 5 elements. Earth, wind, fire, and water. And so earth things want to be at the earth, so they go down. Fire things want to be in the heavens, so they go up. So you get the idea. That's what they want to do. And objects don't really want anything. Okay, that's just what we say. There's another kind of interaction, a violent interaction. A violent interaction is when you make an object do something it doesn't want to do. So if I move a rock up, I have to violently move it up because it wants to be down at the earth. So that's a violent interaction. Another one is if I push that block. The block wants to be at rest. Its natural state of motion, and this is the key, the natural state for an object is to be at rest. So if you want to not be at rest, you have to violently change that interaction. So you have to push it. So here's a block at rest. I just wanted to draw a block. There's really no reason for it. Okay, what about this? What about this interaction? What about if I drop the block? Okay, I'm not really going to talk about falling objects because it's a whole nother thing. Let's just stick to pushing blocks on a table. So here's how we do science now. We use inductive reasoning. And yes, we use deductive reasoning sometimes too, but for the most part, we're talking about inductive reasoning. So inductive reasoning collects evidence, multiple pieces of evidence. And these evidence kind of lead to one major idea. So I see an object falls and it increases speed. I see that in some cases I can get an object moving and it doesn't stop. These lead me to the idea that the natural state of motion is to not change speed, and forces change motion. That's what we have. So now we're back to Galileo, Isaac Newton, and other people. I mean, everyone says, oh, these are Newton's laws of motion. Galileo did a lot of stuff too. So poor Galileo. So the natural state of motion is to move at a constant velocity, which could be at rest. Okay. If you push on an object with a force, it changes the velocity. So why does the block slow down? Well, I'm not pushing on it anymore. It slows down because there is a force. In this case, it's this big thing that people forget about, friction. So that blocks moving to the right, friction pushes to the left. That's why it slows down. It slows down because of a force. And the problem is that we always have friction, so we don't really think about it. So back to Aristotle and Isaac Newton. So Aristotle watches the flying R2-D2, and he says, okay, that's fine. R2-D2 flies with the thrusters pushing him forward to move at a constant speed. If you want to move at a constant speed, you need a violent interaction, and that would be from those thrusters. You have to push forward to move at a constant speed. Newton says no. If his thrusters are pushing forward, he would change his speed. He would speed up, unless there's some other force pushing back the other way. And then Galileo says, why does everyone forget about me? I'm still here, even though I'm smaller. And Galileo would agree with Newton. Okay, so let's make this work. We can make we can make Newton and Galileo happy. How do I make R2-D2 fly at a constant speed? Well, if his thrusters push at an angle, there could be two other forces acting on R2-D2. There's the gravitational force pulling down, and let's suppose there's some air drag force. So he has to push forward to fight through that air drag force. Well, all of these forces have to add up to the zero vector in order for R2-D2 to fly at a constant speed. So if I assume it's like Earth's gravity and Earth like air, and I assume this standard model for the drag force that depends on the velocity, and I can get the velocity of R2-D2 from that video. If you put all that together, and I know the angle of that thrust, it has to both balance the weight and the air drag. So if you have a heavy R2-D2, you need a very, very large drag force too in order to have that angle of thrust. So putting that all together, and I'm skipping all the math, then R2-D2 would have to have a mass of 100 grams. And that's really, really low mass. That's a density of about 1 kilogram per cubic meter. The density of air is 1.2 kilograms per cubic meter. So in fact, I'd have to add another force, the buoyancy force, and it would get even worse. So yeah, R2-D2 flies wrong. Okay. This is where people are now. They're like, hey, come on. You're just a hater. You're a science fiction hater. You hate Star Wars, and you probably dislike Star Trek or something like that. Yes, I like both. Okay. No, I'm not a hater. I'm just looking at the physics. And in fact, I'm okay with R2-D2 flying incorrectly. I'm not so okay with him not flying in episode 4, but that's a different story. But the job of that movie is not to do physics correctly. It's to tell a story. And this is a story that shows R2-D2 with some abilities, and I'm okay with that. If the science is right, that's good, but it doesn't have to be. And that's not the point of the story. And in fact, in this case, flying R2-D2, flying the correct way with his thrusters pointing down, probably would pull people out of the movie, pull people out of the story. They would say, "Why? That looks weird. That's not the way I envision it happening." And that would be not necessarily a good thing. People like the way R2-D2 flies because they agree with Aristotle's ideas of physics. If you push something, it stops. If you keep pushing it, it keeps moving. And that's why they put R2-D2's thrusters pushing him forward as he flies. The end.